Assalamualaikum warahmatullahi wabarakatuh. Welcome to my final year project presentation. My title is Entropy-Based Linear Binary Pattern for Facial Recognition on HSV Color Model. First of all, I will present about myself. My name is Rafiq Shukri bin Zulkifli. My supervisor is Dr. Talikan, my faculty is MJIIT, and my department is Mechanical Precision Engineering. So, without further ado, I will tell about the introduction of the project. One thing that fascinates me is most latest generation of smartphones have facial recognition technology. It is useful in daily life. It is more faster and needs zero effort from the user to log in to the phone. Facial recognition also are being used in airlines boarding, border check between states, Mastercard selfie, hotel check-in, and making an entrance at the events in some of the countries. The facial recognition takes less than 2 seconds, which is really quick, and it is successfully reduced the time by more than 40% compared to regular ways in some of the airlines boarding. Furthermore, a lot of large tech companies are working on facial recognition technologies such as Facebook, Google, Amazon, and Microsoft. Thus, we can imagine in the next few years, more events will be using face recognition. While face recognition are starting to be used more widely, there are a few improvements need to be done. The situation where in the different illumination, different face expression, and different color scheme will affect the successfulness of the face recognition. That's where I think on how to improve the facial recognition so that it will always working no matter the lighting, no matter the skin color of the person, and also no matter what is the expression of the person. For methodology, it is shown here, which is start from the data image collection, conversion image to HSV subchannel, divide the subchannel into region, finding entropy, thus finding LVP from each subregion on each subchannel. Next is forming a histogram of pixel from the LVP and embedding entropy into it, and concatenate the histogram, and the training phase will occur. Lastly, the image testing using the image chosen randomly from the database. How the system is being done? For my case, I will be using MATLAB in most of the project. MATLAB is suitable to be used as it is being used worldwide for different purposes by professionals such as engineers and scientists. It is easy to be used and have many functions that is necessary in this project. The system is being done by calculating the entropy and local binary pattern by using the given color model of a person. By having a few readings about facial recognition, I found out there are a few color codes that needs to be considered in making a facial recognition. The color code that need to be considered is RGB, red, green, blue color code, and also HSV, which is hue, saturation, and value color code. So there is an experiment that has been done before, and the result is HSV color code will give more accurate data, especially for human skin. The method that I done in this research is by using 3 color channels, which is hue, saturation, and value. After the original image were divided into 3 color channels, the image is then divided into small regions. This is to ensure that we have a more detailed data and also to determine the part of the face that has high entropy. In this project, I use Shannon entropy as it is being used worldwide. The entropy were calculated and will be used as data enhancer in next part of methodology, which is LVP histogram. The red part is the entropy that is more than 5, indicating the high entropy area, while the blue part is the low entropy area. Next is obtaining the LBP. LBP is a short form for linear binary pattern. It operates by giving the number of pixels on an image by thresholding the 3 times 3 neighborhood of each pixel. The result obtained will be binary number. This LBP will be obtained in each subregion of the original image. Thus, we get the image of the LBP. Next is the LBP histogram. The LBP histogram will be formed. The histogram shown is the histogram on one part of the subregion, which is I part. It contains 256 data. The histogram is the pixel value obtained from the image from the LBP image. The LBP of the images from hue, saturation, and value is then combined to form a long histogram. This is the process compulsory to train the image. With this long histogram, the weightage or the entropy will be embedded into the histogram. The new histogram obtained is more focused in the middle, as the entropy in the middle is much higher compared to the side part. This process will be repeated for all the training images and for all the subregions. Thus, we get the result from the training and testing phase. The training phase has been done using 50 different images with 50 different persons. To test the data, 10 images were selected randomly from the database. This 10 image is a different image, but it is the same person as in the training image. Our objective is for the system to recognize the image and tell us if the testing image is the right one from the training image. From 10 images, the level of accuracy by using entropy method is much more higher compared to traditional method. By using entropy, the accuracy is above 90% in all 10 images, while without using entropy, the accuracy varies from 67% to 90%. The graph is the comparison between the method proposed and non-entropy method. The proposed method has higher accuracy and more stable compared to non-entropy method. As a conclusion, the method proposed will improve the performance, decrease computing time, and increase the accuracy, especially in different surrounding factors. I would like to recommend for future research to increase the subregion, use more image with more variant with respect to lighting, skin tone, and pose, and also using a different deep learning application. This project will help the future of facial recognition by ensuring the successfulness of each facial recognition even in dim light. The facial expression and the skin color of the person. The facial recognition can further gain acknowledgement as major piece of security, such as in law enforcement agency which uses gadgets with facial recognition to spot the criminal, and in CCTV to widen the surveillance capabilities and make the tracking of the footage to reach criminal faster. Apart from that, in the near future, there will be more and more facial recognition featured system, whether paying online, opening bank account, or going through security point in the airport, as the human face is already a perfect source of data similar to thumbprint. That's all from me. Thank you very much.